So now we are having masterclass on accelerated compute infrastructure for next-gen financial workloads. Our speaker name is Mr. Yogesh Sawant, Senior Solution Architect, NVIDIA. Please join us in welcoming him with a round of applause.
Hey, can you hear me? Okay. Good afternoon, everyone. My name is Yogesh. I look after the AI infrastructure build clustering for NVIDIA. So, I mean, most of the folks here are talking about the AI software piece, but I'm going to talk about how to build this AI factory, which is a new terminology, and the new type of data centers which is required to host the GPU infrastructure. The slide says about financial workloads, but most of the AI workloads are almost similar in a nature. Like if you talk about Gen AI workloads, right? Those are almost similar, and hence the architecture or the infrastructure, what we build or we design, it is almost similar for most of the enterprises, whether it's a financial, healthcare, manufacturing, or any of the ITS organization, right? So first, let's look at the challenges which is on the AI, right? So a lot of people nowadays, I mean, I think till last year we were talking about the POCs of the infrastructure, and now as we in 2025 we see a lot of, I mean, people are at least going in production with the Gen AI kind of, at least LLM kind of application, right? So doing project priorities is one of the important thing which Gen AI project you prioritize. The second challenge we have is the data, because a lot of time the data acquisition, having the clean data for your training or a fine tuning of the model, it's most important. And we saw customers struggling with the data, right? So that's another piece. And the third piece is infrastructure, right? I mean, CPU-based data centers were there from so many years now. We are expertise into that. But when you talk about the GPU-based infrastructure, it is little different. I mean, how does the GPU talk to each other on the multi-node? How does the storage works? Because the storage is most important because your data is there. And most importantly, if you look at the security is one of the concern in the financial, right? So how do we solve that? So I'm going to talk about it. Then the second thing is, because it's a new infrastructure, how do we deploy this, and how does NVIDIA help there? And there is something called time to first token, right? And how does NVIDIA can help on the time to first token? Because when we do a deployment, we make sure that your deployment goes in a scaled manner. So at least you can start training on some of the nodes, and maybe later we have another nodes getting deployed, right? So how does time to first token? So all of these challenges we try to solve with our infrastructure. Before we go there, there is actually a lot of thing in terms of whether I will need this many GPUs or not, right? Because we have the pre-trained model. When the GPT was launched maybe 2 years ago, people were saying maybe only for a training purpose, when we do a pre-training, right, from the foundation model, we will have a lot of GPU requirement. But when those GPT model were available, any public or open source model available, all of the enterprises, right, including financial, where like banks or fintech companies, they take those open source model, and those are general purpose model, right? It is built on the public information. It is not industry specific, right? So we try to do a fine tuning of those model. Now, when the 100,000 enterprises trying to do a fine tuning, your GPU requirement is more, right? And we saw a drastic growth of GPU requirement in enterprise now is too much, right? I mean, it is actually more than the people like OpenAI or any other people who are actually building the model. It is actually huge for the people who are actually doing fine tuning, taking the open source model. Then people thought, okay, my model is trained. Now I can start inferencing, right? In a production, my model will actually start giving me the output, right? But it's not, right? There is something called reasoning model. So if you see something called perplexity or now the reasoning model which DeepSeek is there, right? Now the model actually break down the problem in multiple agents, and then the agents actually trying to solve the problem. Now the number of tokens it generate, right, when it try to answer the question, it is not a very straightforward answer like we saw when the chat GPT was launched. Now it is think, it reasons, and then it kind of give you the research. So we see The pre-training was a school, the post-training was a college grad, and the thinking layer is the PhD or a master course, right? I mean, the model has to be continuously trained. And how does it happen? So you have this AI factory requirement. I mean, what do you need for the AI factory? So we divide this into two pieces. One is the hardware, which is everyone knows what NVIDIA builds, but everyone only knows NVIDIA only builds the GPU. But there is more to that, which I'm going to talk about it and why it is also important for it. Then the second most important piece here is the software stack, which I will talk very briefly because it doesn't comes under the infra, but I'll talk about it briefly, maybe some of the use cases specifically the banking is trying to solve, and how NVIDIA can help on those use cases. Because we are not only uh, NVIDIA is not just a chip manufacturer. Our software stack is so big, I mean, or maybe a solid, that we actually have open source models which are equivalent to a lot of open source model available in the market, right? And I'm going to talk about it. But most important thing is there is something called, if you see here, electricity, right? This is becoming more crucial and more important because the data center where you want to deploy this model need different kind of power requirement today, and we have not actually thought about it maybe a year ago or 2 years ago. And the GPU models which are going to deploy the infrastructure requirements are completely different in the power and cooling perspective. So I'm going to talk about it on the what is the current GPU power requirements and what are the future requirements for the data center perspective. Now, when you have a AI factory, so when we talk about AI factory, is basically providing the electricity to the model, and then maybe electricity and the data to the compute, and then it is giving us the intelligent tokens out of it, right? So how does it happen? So you have a foundation models, which you deploy on your infrastructure, and then start doing a fine tuning, because the model which you get, right, it's public information. It is not specific to your industry or a vertical, or it doesn't know about your specific enterprises. So you have to do fine tuning of that model. Either you can do fine tuning using SFT, LoRa, or you can actually use RAG based models to do that. But when you do that also, right, there is a new data is also generated every day, right? And that is on your storage. So you keep on training that model until it actually gives us the right answers and based on the new data, right? And all of those things, how does you do it on the infrastructure is called as AI factory. So you give a data as an input and generating intelligent token is the output of it, right? So that's what we do in the AI factory. Now, there are multiple ways you can deploy this. One is we work with most of the OEMs, which is a server manufacturer. So you can actually work with them. We have a certified solution with them with the GPU systems. And then we have a certified storage platform. Now, either you can actually deploy this on your own on-prem data centers based on the power and cooling you have availability, or we have a certified data center partners in the country who are certified to deploy NVIDIA-based GPU solution. The another option is you can actually have ready-made NCP stack, which we call NVIDIA Cloud Partners, which is like a tier 2 service providers which already have hosted the GPUs, and they can actually give you the shared infrastructure where you can actually use the GPU for training and the inferencing perspective. Or any other one is we have tier 1 service providers also, like of AWS or Google. They can also provide those GPU infrastructure, right? So there are multiple ways you can actually consume this GPU, and there are various software stack, hardware stack involved here, which NVIDIA offers. Now, we believe in reference architecture. Why we believe in reference architecture? Because, as I said, the GPU infrastructure is different than the CPU infrastructure. I mean, the CPU data centers, right? And whatever we do, we have our own engineering labs, and this is not a very small lab. These are like massive labs or engineering clusters, I would say. Those are also part of the top 500 HPC clusters. And we actually tested this GPU system before customers goes and deploy it. And based on those infrastructure, we try to create a reference architecture, which include GPU, CPU, networking, storage systems, and the cluster management infrastructure software stack. Even we have our own model called Nemotron, which is equivalent to Llama or maybe GPT, which we also use to benchmark on these engineering clusters. And then once we have those numbers, the benchmarking numbers, both for training and inferencing, we try to replicate the same thing on the customer infrastructure. And because Gen AI, I mean, anything to do with the banking or anything to do with AI has to be secure. So we provide security from the infrastructure perspective. So we can actually deploy this with the multi-tenancy kind of infrastructure where multiple tenants can be part of the this GPU infrastructure. Or we can actually also have software stack for the guardrailing of the Gen AI models, right? Where the model should not be drifting from its own purpose. It should not drift from the while it answering. So we provide the secure infrastructure both from the infra side, which is our hardware side, and also from the software stack perspective. Now let's look at what are the platforms we have available with the thing, right? I mean, from the compute perspective. And how does the interconnect happens within the systems, right? So we have this different kind of GPU systems. So if you look at the first right one is the rack-based platform, which is the latest Grace Blackwell GPU platform. This is like a 72 GPUs in a systems, and it's kind of massive GPU cluster, memory coherent system we're trying to create here. These are mostly used for the LLM trainings, like a trillion parameter models or trillion parameter inferencing. This is the latest systems which right now we don't have in the country, but we are working with some of the service providers to bring this in the country and deploy for the training and the inferencing perspective, right? We have one of the software company from India which is using this kind of GPU systems outside India to train their models, primarily the Copilot based systems. Okay. The second one is most important. This is what most of the customers in the country using it. We have tens of thousands of this GPU deployed in the country. These are called as XSM based GPU. These are connected using something called NVLink. We can have 8 GPU in a system, and then we can have networking to interconnect more than that. This is primarily used for the LLM training or maybe large model inferencing when your model size is pretty big. Okay. Then the third one and the last one is a very maybe small inferencing PCI based GPU. These are primarily various models we have. The latest one, the RTX 6000 Pro, which is based on the Blackwell GPU architecture, which provides you 96 GB. And the most important thing here, right? This two system, whatever you see in the first, requires massive power in a data center. Like the first system needs close to 125 kilowatt per rack, and it needs liquid cooling kind of solution, right? So today, we are working with the data center infrastructure providers to build a data center to host this kind of system, because we don't have infra today in the country to host this kind of GPUs. But the second one is pretty there. But I mean, the GPU power goes close to, I will show you, close to 12 to 14 kilowatt per system. So hosting in a per rack, maybe some of the service provider can host only one system or maybe two systems. So networking costs become expensive because you have to interconnect those with the optical transceivers. If it goes on a single mode, then the optic cost is going to expensive, right? So we try to avoid those kind of solution with the more power per rack, so we can host more system in a rack. And this is how important for you to host this. Now, if you look at the RTX Pro, which is the latest one, this is primarily designed for, I mean, most of these GPUs are primarily designed for the inferencing use cases. And I would understand that most of the enterprise customers or banking customers are going to do some kind of fine tuning or maybe LoRa based fine tuning of the model on the open source model, and then start doing inferencing of the your AI model, right? So this systems like PCI based system, these are useful to host inferencing of the models, right? And this can be like I mean, you can host Llama 70B kind of model on the single GPU from the RTX 6000 Pro to an H200 NVL system. Now, this is slide just to depict, I mean, to give you understanding how much power is required. So the 8 GPU systems with the XSM-based GPU will need close to 20 kilowatt. I mean, start from 12 kilowatt to goes up to 20 kilowatt. So you have to plan your power accordingly. If you want to do maybe a PCI-based GPU systems, you can do up to maybe start from 5 to 7 kilowatt, can goes up to 10 to 12 kilowatt, right? So you can plan your infrastructure accordingly based on the use cases, right? So XSM based GPU we primarily use for the training purpose. PCI based we try to use for the inferencing purpose. And this is just to show you how does the roadmap look like. This was announced in last year GTC by our CEO Jensen. So if you look at the GB200 or Blackwell based GPU, this is NVL 72, meaning the previous generation I show you was 8 GPU in a system, but this is 72 GPU in a single rack, talking on a single memory coherent. And the next generation, what we are trying to do with by 2026 or 27 is having 576 GPU in a single rack, and with our latest generation Vera Rubin GPU system. Okay, so we also started doing CPU-based ARM-based processor as well, and we also have the GPU interconnectivity better on those systems. Now, I included, little technical here. When the GPUs are there, like not the PCI, if you look at, if you place a GPU on a PCI slot, the communication between GPU is depend on the PCI speed. And for any model training, you need more GPUs, and the GPU job is spread across parallelly across multiple GPU cards or a GPU nodes, right? When you depend on the PCI based speed, your more time goes in a communication rather than the compute. So we started doing something called NVLink, which is our own technology, where the GPU interconnect on a very high speed burst bandwidth, goes up to 900 gigabyte for the previous generation, and for the latest generation it is 1.8 Tbps. This is specifically for the large models where now the models are increasing, and there are mixture of expert model where multiple models are trying to write to a single model, and then the communication problem keep on increasing. So for this we have now started doing NVLink based, NV switch based system. So now there is a switch system called NV switch, which is part of the solution, and this will provide you 1.8 Tbps for the current generation GPU. And this is for the 72 GPU connecting to each other on the single rack basically. Now, if you think about it, I spoke about the GPU, I spoke about for which type of the GPU, for what purpose, and I just spoke about the communication between the GPU. Either you can do PCI, you can do NVLink, right? Now, when you have a system, let's say you have 8 GPU system, but for your training purpose, you might need, let's say, 32 GPU, right? Now, how do you interconnect those? So we have a dedicated network we create for this, which is we call as east-west network. And when the GPU communicate to each other, this is most important. You cannot use the standard Ethernet-based systems or legacy Ethernet switching system for this. We prefer something called InfiniBand, which is our own technology. And we also now started doing Spectrum Max, which is our Ethernet-based solution for the GPU communication. Now, why it is most important? The AI workloads are work differently. The flows are, you have very less number of flows, but there are flows called elephant flows. Those are a lot of flows are there. So your infrastructure or networking should be lossless and the low latency to handle this kind of flows, right? So by default, InfiniBand is the lossless fabric because it works on a native RDMA, right? To make it Ethernet lossless, we have worked with something called our NIC cards plus Ethernet switch system to make it lossless and native RDMA ready. Okay, and if you look at, there are 3 important network infrastructure in the GPU clustering. First is east-west network we call, which is used for GPU to GPU communication. This is only to connect GPU with each other. Let's say you have 32 GPU and you want to communicate, this network will be used. Now the second network, which is most important here, is a storage network. Why? Because in a training job, you will have read performance, like your data will be stored on a storage platform, and this network will be used to read the storage information, right? So this is also become critical. And the third network is, which is everyone has, which is the out-of-band network. This is also used for managing the systems like nodes, or we can actually use this for the PXE booting of the operating systems. Now, these are the networking stack we have. So we spoke about NVLink, NVSwitch. This is within the system, and with the new generation, it is actually coming outside the system, right? Then we have 2 major networking stack. One is InfiniBand, which is the by default native RDMA lossless infrastructure networking stack for the GPU communication. We also have a Ethernet-based Spectrum X-based stack, which is also used for the GPU to GPU communication for the east-west networking. Then we have something called DPU card. This is a NIC card coming with the CPU processor to make it Ethernet network lossless. So we call the solution with the Ethernet switch of our own, along with the our Bluefield 3 DPU card as the Spectrum X solution. And this is the lossless solution for the AI fabric. Okay. Now, so I spoke about the CPU, GPU, NVLink, and I spoke about networking stack, but we don't make it storage fabric, right? I mean, we don't have a storage platform. So, and why it is important? If you see the model size today are getting, exponentially increasing in terms of the number of parameter it has, right? It comes from the billion parameter. Now we are talking about the trillion parameter, and in a trillions also we see there are 10 trillion parameters models also coming, and in future it's going to grow only, right? So storage system become extremely important because your all the training performance or all of your checkpointing when your GPU fails, it is depend on the storage performance. So we work with a lot of these storage vendors. Uh, Primarily, these are the certified storage vendors. And as I said, we have our own engineering clusters in our own data centers. We take these systems from the storage vendors and certify this in the engineering clusters. And there are specific model only certified. So when we work with the customer, we try to explain them the performance important for the training of the data, right? And this is why we have certain performance number when we do this testing. We also tell to the storage vendors and also to the customers while they design the infrastructure. Now I spoke about the hardware part, right? So you have all the clustering. Let's say you have GPU, you have network, you have storage. Now how do you set up that? Because you have east-west network, you have north-south network, you have storage systems, right? And then you have to run the AI workload on it. And most of the AI workloads are microservices based. These are container-based software stack. So we have something called mission control system from where I can install the operating system, I can install the drivers, firmwares. I can also install the Slurm or Kubernetes, which is also important to run this GPU job. I mean the workloads basically. And then once you start doing it, you have to monitor the infrastructure. How does the GPU, whether it's the healthy, the temperature, the GPU memory consumptions, everything, right? And as the systems are changing drastically, we are also doing liquid cooling in the future generation system. We are also now started monitoring the BMS part of it. Generally, the BMS is not part of the IT monitoring, but we now started doing BMS monitoring from the power consumption, from the liquid flow perspective. Maybe there is a leak detection. All of those things are monitored in this mission control system. The next thing what we are trying to do here is, because when the job fails, you have to monitor what exactly failed, whether it's a software failure, whether there's a hardware failure, or whether there is maybe a driver failure, right? So we keep on monitoring that, and we try to do automated run test where what is exactly failed, and when it is failed, it has to be manually restarted, right? But with the automated recovery, we can actually start automation of recovering the job automatically. If there is a hardware failure, the job will automatically move to the next hardware. Or if there is a driver failure, we will fix the driver. Everything this is automated with the mission control system. And this is part of our NVAI stack. And this is most important software stack from us, right? So you have infrastructure, which is providing this cluster management software stack. And then we have a software stack, which is called as Nemotron and NIMS. These are the software stack available from NVIDIA. And why this is most important? Because you can say, you have open source models available on Hugging Face and you can use it. Definitely, you can use that. But we try to optimize those models to efficiently run on our GPU. So we give you the benchmarking. If you use the open source model, just like that on our GPU, the performance will be X. But if you use our own models, which are on our NGC website, which is freely available to download, we optimize those models to run on our GPUs. So you will need maybe less number of GPU to run those jobs. Now, all of these models comes in a package called NVAI. So whenever you need to do a vulnerability fixing, and in banking this is most important, right? Because you can run the model, but when there's a vulnerability, you have to fix that. All of those is taken care by NVIDIA. Even if whatever open source models are there, those are available on our NGC container website, and you can download free of the cost. Only for the support purpose, you will need a licensing from us. Now, if you look at, now I just come to the banking industry, and this is important, right? In a banking, right now, most of the use cases are around customer satisfaction and the customer services, right? How better customer experience I can give it to the customer. So there are some models available with us, or we are actually working with the customers to develop some fine-tuning model with the banking customers today. The second most important is the document management, because in the banking there are so many documents. And I was talking to one of the bank. I mean, we were doing a workshop with one of the bank. Then there was some operational people who mentioned that he wanted to search certain audit thing in one of the document, and there are tens of thousands of document, and searching that in a standard enterprise search is very difficult. With the document management automation with the AI, we can actually find out the things very easily. And this is, I'll give you the example, right? Today in our organization, and this is not to only banking, any industry. Today, if I'm from NVIDIA, if I want to search how much Mediclaim I have, I will definitely spend 15 to 20 minutes to first find out where is which link, which document, and then how much is that, right? And if I do a RAG for that, let's say, that's simple. If I take a Llama model and use a RAG, and if I fire a query, I will get answer in few seconds. So I can save a lot of time of the employee, because when you save a time of employee, it is $1 for you, right? So employee search, employee experience is on another use case we try to look at. The another one is definitely fraud management. This is critical one. Even you can see with NPCI, we have done the model. We have used our libraries to do a fraud management on our own GPU. They are using that model, right? Risk assessment is another use cases for banking industry. The another one which is we are also doing is the marketing with some of the banks. So marketing campaigns can be automated with the our NIMS model which are available, or maybe we can actually do fine tuning of the existing model, and we can generate certain models. So all of these things. So it's not only about the software. I mean, sorry, hardware, right? It's not the chip or a networking or a infrastructure. We are also helping customers from the software perspective. We work with customers to do provide the fine tuning or maybe deploying these models efficiently on our GPU as well. Another thing what we have done, I mean, I don't know how many of you know there is something called NIM, which is NVIDIA inferencing models, microservices models. But we have gone ahead and we have developed certain things on something called blueprints. So if you go on this website, build.nvidia.com, you have ready-made, I would not say application, but a complete package solution for certain use cases. So if you take first experience, I mean the first use case, which is customer experience, right? And this is also required for banking, maybe an AI chatbot or an AI agent which can answer certain queries for our customers, maybe for the internal employees, right? The complete blueprint, including the model, the RAG pipeline, then maybe a vector database, is completely pre-packaged and provided as a solution. You can just download this from the website, can run as an endpoint and connect to your application. So your AI journey can be much faster. I mean, just giving you example from the banking industry. The second one, like the data extraction, right? Again, we can do data extraction blueprint, just a click on this website. I mean, go on our website, click, download the model. I mean, just pull, because it's all containers, right? And then we can start doing document extraction. So there are a lot of blueprints which are available. Virtual assistants, right? Those are also available. So you can actually start using this. Maybe you guys are infra guys, but if you can explain this to as a data scientist team, they will also understand how easy to deploy this model with the NVIDIA blueprints. And as I said, we have our own infrastructure deployment team, and this is most important, right? Maybe in an initial 1 or 2 installation, this is important because you have different kind of infrastructure here. One is networking, the second one is a storage, the third one is the cluster management, and most important is whether your deployment, whether it's your GPU to GPU communication, GPU to storage, maybe to your own network where the requests are coming for the APIs, right? Whether those are efficient or not. We can actually deploy these models, entire hardware along with our software stack, required operating system, firmware, drivers, everything, and we can actually do benchmark. So once we are clear that okay, this cluster of, let's say, 32 GPU or maybe 64 GPU is working as expected, or maybe thousands of GPU, right? Then we can hand out to the customers, and then customers start doing fine tuning of this model. And this is most important because it's not like a standard CPU based infrastructure. We have our internal engineering team works with our cluster management team, and then we deploy this with our customers. And we also do a training or a KT session once we deploy this model. And maybe second time you can start deploying this model yourself. Now we have a lot of partners where we work. So we have OEM partners where people can go and use these GPU systems. I mean, there are certified systems with most of the OEM. Then we have a CSP partners, which are where you can actually on the cloud, if you don't want to build yourself, you want to consume on a cloud, these are the CSP partners where you can actually use. Then we can have partners such as storage partners, Veka, Vast, or Salesforce, where we have own agentic models already deployed working with them, right? So we work with most of this organization to make sure that the AI is delivered perfectly to the customer. Now the last slide, I'm just finishing early. When you deploy a reference architecture, which is based on our documentation and the guidelines what we given to the customer, right? You can have this kind of saving, right? There's nothing, you can actually use anything to deploy any network or any storage system, but you will not able to get optimized performance or a efficient performance on the infrastructure, because we have also tried doing that on the different platforms and we don't get that in performance. Hence, we have done a lot of engineering to make sure that you get a optimized performance, because these GPU systems are expensive, right? And then other thing is deploying these GPU systems is not, we don't have expertise in the market, right? So we make sure that from the hardware stack until the software stack, we work with the customer, deploy the system, and help them to do optimized way rather than doing yourself. So this is one thing, and you will see a lot of these improvements. And even let's say there is a H100 model, I'll just give you an example, is giving, let's say, 100 tokens per second for the older version of the firmware. We will improvise that with the certain new firmware, and maybe the performance on the same GPU will be increased. And all of these numbers you can actually track on MLComs, or there is this website where the training numbers are published publicly, or maybe the inferencing benchmark are also published publicly, and you can actually compare the results from the old performance numbers and the new performance number, and you can actually see there is a drastic difference. And this is because our software stack is improved every time, and we try to work with the customer to make sure that they are using the right software stack, so you'll get a more optimized performance out of this fabric. So I think that's it from my side. I did little quick. Maybe I saved you 14 minutes, but thank you very much for this. I hope this is interesting. I think there is you can ask the questions on the chat in the GFF application. Thanks.